To decompose the question in 3D into its partial fractions, we have to first of all recognize that we have this type 2 involved. So that x minus 2 all squared, make this the type 2. But we also have this x plus 1, extra x plus 1 factor. So we have to make sure we account for that as a type 1 as well. So when I decompose this, I need to know how to set this up. So I need to first of all account for my type 1. So I'm going to do my x plus 1 first. Okay, now you don't have to do that first, but this is how I'm going to separate it out. And then I also have the type 2 part, which has two parts to it. And the parts that we have are going to be the x minus 2 just as a single factor, and then the x minus 2 as a squared factor. Okay, and then I'm going to have my coefficients b and c on there. Okay, so when I get my common denominator, okay, I'm going to do this color coded this way. So I have my x plus 1 term. I'm going to do that as when I need to multiply the top and bottom of this by the x minus 2 factor. So my equation ends up being like this: a times x minus 2 squared plus the b term, okay, which I'll do in maybe green here. The b term, this is missing a factor of x plus 1 and x minus 2. So it's going to be b times x plus 1 and x minus 2. And then plus for the c, that one's just missing an x plus 1 factor. So this one here, I'll do it in red. It's going to be c times x plus 1. And that's going to be equal to the original numerator of 18x squared minus 19x plus 0. Okay, again, just going to highlight that here. So that numerator ends up being the calculation for that denominator that we've expanded out. Okay, so there's a few ways to do this. Now, I've shown two strategies in the notes. One of them was, and this was the second strategy that was in the notes, was making zero factors by choosing x's to make zero factors. And this one kind of lends itself to that strategy. So for example, if I want to get rid of the zero, or get rid of the a coefficient and b coefficient, I can just plug x equals 2 into that expression, and I get zero factors for a and b, and I'm just going to be left with c. So that's what I'm going to do first. I'm going to try that strategy. So I'm going to let x equals 2. When I do that, I get a times 0 plus b times, this will be 3 times 0. And the 0 is what I'm looking for, because that eliminates those two coefficients. Plus, and I can put the x equals 2 into here, and I get c times 3, and I just plug x equals 2 into this expression. So I get, so that's not 18, that's going to be 8. So I plug x equals 2. I get 2 squared times 8 is 32. And 2 times 19 is 38. So I end up with basically 3c equals negative 6. That makes my c value equal to negative 2. So I've solved for one of my variables. I can do the same. I can do that with x plus 1, and that will get rid of the b and c coefficients. So if I let x equals negative 1, I'm going to end up with a times negative 1 minus 2 squared is positive 9 plus b times, well, I get my 0 and a negative 3 here, plus c times my 0, and that's going to be equal to, when I plug negative 1 into this, the right-hand side, I get negative 1 squared times 8, that's just 8. Negative 1 times 19 makes this plus 19. So I end up with 9a. All the other terms cancel out because of these zeros in here. So I end up with 9a is equal to 27. A is equal to 3. So I've solved for 2 out of my 3 coefficients. I just need to solve for b. Now for b, I have to be a little bit more creative because I've kind of run out of factors of a for the x's in the brackets because there's only an x plus 1 and x minus 2. However, since I already have a and c, what I can do is I can just plug in some arbitrary number for x, and that will just leave me with one variable b to solve for. So the easiest number to plug in is usually going to be x equals 0. Now, this is arbitrary because I could have chosen any number for that last one. So when I plug in x as 0, I get 0 minus 2 squared is 4, so I get 4a. But I already know that a is equal to 3, so I'm just going to replace that with a 3. Replace a with a 3. Okay, and where is that coming from? That's coming from here. Then I'm going to plug in for b plus b, and I'm going to end up with 0 plus 1, 0 minus 2. I still don't know what b is, plus c. Well, I do know what c is. Okay, I know that c is equal to, in this case, c is equal to negative 2. So I'm going to do negative 2 for c, and then plug in x is 0, and I get 1. Okay, so I'm just going to rearrange this. This was the coefficient part of that. That was the a value. This was when I plugged in 0 into the brackets. Okay, and then I still have to put 0 into the right-hand side of the equation. Well, the nice thing is this 8x squared minus 19x is just going to be equal to 0. So I only have, although I don't have zeros on the left side, I only have one variable left to solve for. So I have negative 2b, and that's going to be 12 minus 2, and then that's going to be 10, and I'm going to move that to the other side of the equation. I get negative 10, and I get b is equal to positive 5. Okay, so just color coding some of this stuff. The c ended up being negative 2 in there, and maybe I'll color the b equals 5 as green. So I've now solved for all 3 coefficients on that partial fraction. So if I were to write that partial fraction, then my partial fraction works out to be, I just need to make this a little bit smaller so I can see the rest of it. I end up with a, which is going to be 3 over x plus 1. I have plus b is 5 over x minus 2 plus c, which we worked out to be negative 2. So negative 2 over x minus 2 all squared. Okay, and breaking down this into partial fractions like this, now I can actually integrate all 3 of these. I can integrate the x plus 1 in the denominator with log, x minus 2 in the denominator with log, and the x minus 2 squared using the power rule.